So here's a more complex example of using dimensional analysis. The fundamental frequency of a stretched string can be found by using the formula F is 1 over 2L times the square root of F over mu, where L is measured in meters, F is in newtons, and mu is mass over length, where m is in kilograms. Find the unit for F. Now this here guy mu in this case stands for mass per unit length. So it essentially means that if there's a string here between two posts, and say it has a length of 3 meters and a mass of say 0.6 kilograms, then if we chopped off a meter of it, so if we sort of split it into thirds, kind of like this, then the value for mu will tell us the mass of each of these 1 meter long segments. So this here would be 0.2, which would be our value for mu in this case. It also means that if there is a string between two posts and is not necessarily a meter, so let's say it's 0.25 meters for instance, and it has a mass of 0.1 kilograms, then if it was stretched to a meter, then mu would tell us that we multiply this by 4, so it'd be 0.4 kilograms per meter. So that's essentially what mu is in that case. With that out of the way, I recommend you try this problem, and I will reveal the solution now. So you can pause the video, try it, and unpause when you're ready. So I told you it was going to be a very complex solution, but here it is. So we've written the formula 1 over 2L square root of F over mu. Now mu is in kilograms per meter, and F we already know is 1 kilogram meter per second squared, so we substitute that in. Now dividing by a fraction is the same as multiplying by the reciprocal, so we have 1 over m on the outside, remember the 2 disappears, and we have kilogram meters per second squared divided by kilograms per meter. So that's the same as kilogram meters per second squared times meters per kilogram. The kilograms obviously cancel, and we get meters squared over second squared. And that's the thing that we have in the bracket. Now, of course, meters squared per second squared, you can bring, because they have the same index, you can write meters per second all squared, sort of reversing this law a bit. So these are equally true statements. Now, of course, the square root and the square cancel. And we get the meters will also cancel, forgot to mark that. So F is measured in per seconds. Now, this is frequency, this is what F is, and the actual unit is cycles per second. You can note the per second and this here. Much like the Newton, we came up with another unit to honor a physicist, and the unit of frequency is known as a hertz. So you may have seen hertz be used a lot, especially in computer monitors. Now, computer monitor hertz is different from frequency hertz, kind of. The frequency hertz is cycles per second. The frequency of a computer screen is more akin to how many frames are being outputted per second. So it's a key distinction to make, but it is at least a commonly used unit, the hertz.